In this video, we're going to have a look at the basic transformations of the function y equals x squared. Notice the symmetry in the function. Notice the turning point passes through the point 0, 0, and then on either side of the turning point, if we step out 1, we step up 1. So across 1, up 1 on both sides. Let us consider the so-called dilation factor. A dilation factor is when we add in a scalar or a multiplying factor in front of the x squared. Notice what happens in this example. If we have y equals 2x squared, and then we have a look at that in the table of values, notice that these values have increased by a factor of 2. If we have a look at that on the curve, we see that the curve has now become steeper or taller and skinnier. Now if we have a look from the turning point, notice that the turning point hasn't changed. The turning point is still at 0, 0. If we step across 1, we now step up 2, which is the same as the dilation factor. Another example. Notice our dilation factor is now negative 1/2. If we substitute the values of x into the function, we get specific values of y, as shown in the table of values. And if we view that visually, notice once again the turning point has not changed. However, now the graph is reflected. That is because of the negative in front of the dilation factor. So when we have a negative in front of the dilation factor, the graph is reflected. Notice from the turning point that we now step across 1 and down 1/2. Step across 1 and down 1/2. This relates directly to the dilation factor. Just to recap, the dilation factor affects how steep the graph is. If the absolute value of A is greater than 1, then the graph is tall and skinny. If the absolute value of A is between 0 and 1, the graph is short and flat. We've also seen how the sign of the dilation factor affects the direction of the curve. A positive A value means that the curve is smiling. A negative A value means that the curve is frowning. One point that's really important to remember is to find the points either side of the turning point, we need to go across 1 and up and down A. Pause the video and have a go at this example here. Remember that when you're sketching a function like this is the basic form with only the dilation factor added in, so the turning point is still at 0, 0. However, the graph now is tall and steep. We have to step across 1, up 4 on both sides to get the 2 points either side of the turning point. Now consider another change we can make to the basic function and add in a horizontal translation factor. Horizontal translation factor is a number added within the square with the x's within. So you have x minus something squared or x plus something squared. Let's use this example, y equals x minus 1 all squared, to have a look at the table of values and also the graph to see how that changes the turning point. If we have a look at the table of values, we can see that these are slightly different to the examples that we've had before. No longer is my turning point centered around 0, 0. My turning point is now at 1, 0. Because the dilation factor in the function was still 1, I still step across 1 and up 1. Notice the connection. If h is a positive 1, I step to the right by 1. My turning point shifts to the right by 1. Let's have an example if we have a negative h value now. So let's have a look now where we have an example where h is equal to negative 2. Now this could be written in two ways. We could have x minus negative 2 all squared or x plus 2 all squared. This can sometimes be confusing for students because they see the positive 2 inside the brackets and they assume that h is positive. However, considering the general form where it's x minus the value of h, if we have an addition inside the brackets, we know that we must have a subtraction with a negative number. So this is an example where we have x minus a negative value of h. Now, let's have a look at the values substituted into the table of values. And this is what the curve looks like if it was sketched. Notice that my turning point has now moved across to the left by 2 places. So my h value is equal to negative 2, and I've moved to the left by 2. In the first example, my h value was positive 1, and I've moved to the right by 1. In the second example, my h value is negative 2, and I've moved to the left by 2. Therefore, in summary, if we have a horizontal dilation factor of h where x minus h all squared is equal to y, if the h value is positive, so we have x minus positive h, the turning point moves to the right. And if h is negative, that means we have x minus negative h or x plus h, the turning point moves to the left. Pause the video and have a go at these 2 examples. Attempt to sketch these functions without drawing the table of values, and only do it by moving the turning point. In both of these examples, I've no longer drawn up the table of values. All I've considered is the dilation factor and the horizontal translation factor. In both of them, a equals 1, which means from the turning point, we step across 1 and up 1 in both directions. And to find how far the turning point's moved, I just look at the h value. In the first example, h is positive 3. That means the turning point moves from the origin to the right by 3. In the second example, h equals negative 1, which means that the turning point moves from the origin to the left by 1. We'll now consider the vertical translation factor. In the general form, we'll see it where we have x squared plus k. So the k is outside of the square compared to the h, which was inside the square. Let's look at this first example, x squared plus 1. If we have a look at the table of values, we've just subbed the values of x into the function to get the values of y. If we have a look at the sketch, we can see how that vertical translation factor has changed the turning point. The vertical translation factor is 1, and the turning point has now been moved upwards by 1. Let's have a look at this second example. Y equals x squared minus 2. So that means that the vertical translation factor is minus 2. If we have a look at the table of values, we've just substituted the values of x into this table of values. If we have a look at the sketch, we can very clearly see how the vertical translation factor has changed the turning point. So if the vertical translation factor is positive, the turning point moves upwards. If the vertical translation factor is negative, the turning point moves downwards. To recap, the vertical translation factor, if k is positive, the turning point moves up. If k is negative, the turning point moves down. Now, let's try it all together, where we have a situation where we have a dilation factor, a horizontal translation factor, and a vertical translation factor. Pause the video and have a go at these 2 examples. Before you attempt sketching, write down the values for A, H, and K and describe what they do to the curve and to the turning point. The first step with any of these functions is to always write down a, h, and k. And for the moment, write down the description of what happens to the curve and what happens to the turning point. Once we have the description of what happens to the curve and what happens to the turning point, it is relatively easy to then mark these points onto the graph. So first of all, we mark in the turning point. So with this first example, we go right by 1, then up by 2. And to find the next 2 points, we use the a value across 1, up 2. With the second example, we first mark in the turning point, which means we have to go left by 3 and down 2. And then to mark in the second 2 points, we use the a value and we go across 1, down 1. Remember when you're doing these to write out the a, h and k values separately. Go a step at a time and just ask yourself each time what happens to the curve and what happens to the turning point.